Hello, and welcome back to Quantitative Reasoning Online. Today we'll be doing the tutorial for the Part 9C preview assignment. And let's see, what is its title? It is titled, How Much Should I Be Paid? Whatever it is not enough. With 3 questions. So let's do the tutorial first, and then we'll follow up with the questions. That's nice. And let's adjust the boundaries, which are here and here, somewhere. All right, let's see. 9C preview. We will understand the meaning of the word univariate and bivariate. Unit is 1, bi is 2, variate means variable. 1 variable, 2 variable data. Compute the measure of central tendency for a data set. Mean, median, mode. Read a graph that includes information about 2 variables and determine how the variables are related. Okay, scatter plot. Read and interpret information about engineers. Hey, warmed my heart. So let's move on. Okay, in the next class, you will continue your exploration of different kinds of data. You will revisit measure of central tendency, mean, median, graphical displays, the histograms, scatter plots, and line graphs. The tool for preview lesson 9, part C, starts here. So let's see, here we have income of 20 engineers. Now let's see, make sure we got 20 here. We got 22 lines, but one is a header, one is a sum, so 22 minus 2 is 20. Alrighty. Alright, so let's see, income of 20 engineers. This is an example of a univariate, one variable. Dave, because we know one thing about each engineer. We could have increased, kind of like I said, like a x or n, and it'd be 1, 2, 3, 4. With each number basically equating to an engineer. Engineer number 1, 37,000. Engineer number 2, 42,000. Engineer number 3, 42,050, and so forth, and from low to high. Find the sum. Okay, we have the sum. The question is, find the average annual income. Now, the average annual income, x bar, is going to add up all the x's and divide by how many. We know the total, 1,325,310. Yep. Divided by 20. So what does that get us? Clear. So 1,325,310 divided by 20 for 66,265.50. Add them up, divide by 20, 66,265.50. All right. What does this guy do? Brings up that graph, actually, with that table. Okay. And see how this, yep, sums it all up. Uh-oh. All right. Something else we could have done with data is mean and And so I could have also done equal what? I want to do some formulas. It's a statistical thing, and find an average. Average of what? Of all that. Got the same thing. Or equal what? The sum divided by 20. All the same thing. Same way of getting the same answer. All right. Close screen. So, numerical data, after being arranged in ascending order or descending, can be grouped by relative size. The median divides the data into two sets. Half the data set is in a set of smaller values, and the other half in the data set of larger value. Find the median income of the 20 engineers. All right. Now, median isn't really looking at these numbers. It's really looking at position. I'm going to go to here because it's easier to do. It's really looking at position. I can make some extra room here. Okay. And what's the position? All right. It's going to be the location, where basically you're at the halfway point. Half your data set's up here, and half your data set is down there. Well, so how do you find your halfway point? Well, figure out, and we're going to call these, quartiles. That would be basically the what your total number of x's. In this case 20, halfway, so 0.10. Okay. Except I think I said this earlier in a section, that if it's even, what you got to do is, it's not going to be the 10th location, but it's going to be halfway between the 10th and 11th, so we got to average these two guys together. So the median annual income that's going to be basically the 10th. Why is it doing this? The 10th position plus the 11th, divided by 2. So 56,900, which is x10, 62,430, which is x11, and average it. Okay, so 56,900 plus 62,430 is 119,330 divided by 2, or 59,665. Of course, 59,665 fits right in between those two values. $59,665 Oops. Right there. Solution, the 10th engineer earns that, 11th that, the average of those two salaries is 59,665. Yeah, so you have to remember the median and I'm just going to subtract 1. Subtract 1. So it'll be between this guy and that guy. Because above that location, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Less than that or more than that is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 10 below or 10 above, higher, and 10 below that value. And that's the median. Quartile value divided rank data into 4 equal groups. First quartile is the median of the smaller half data, below the median, find the first quartile income. Okay, well, here's the median. And what was that again? 59,665. All right. Okay, so here we have 10. 10 pieces of data. So what's half of 10? So quartile 1 should be located at, well, 10 over 2, which equals 5. So it should be between the 5th and 6th number. So again, 1, 2, 3, 4, 5, 6. Ah, that's why. Okay, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6. So your quartile 1 should fall between there. Because above it I have 5, below it I have 5. Or 5 lower numbers, 5 larger numbers. So that should be the 45,005 plus 5,200, 2,000 divided by 2. 45,005 plus 5,200 divided by 2, or 48,502.50. Solution. The 5th engineer earns 45,005, 6th 2,000, 45,250. Which is what we got. Let's see. Here's my median. 59, I think 665. Let's see. Here's my Q1. Oops, wrong button. 48.5, which is 48,502.50. To find the third quartile. Well, the third quartile would be halfway in that upper portion above second quartile, the median. You're going to have 10, So so again, we have 10 locations. So it should be the fifth one. So 1, 2, 3, 4, 5. And make sure there's 5 below it. 1, 2, 3, 4, 5. So 5 above, 5 below that value. And again, it falls, it's an even number, because with an even number, a whole number, we have to kind of split between that one and the next one. So this would be, what, 80,000 plus 80,250 divided by 2, which should be $80,125. What do we get? 80,125. Alrighty. Okay, now let's look at information from a customer bill for the use of propane. Graphic shows the total monthly energy cost plotted against the average monthly temperature over a 2-year span. The graphs are displayed on the same grid using the same horizontal axis and scale of the months from February to January, 12 to January 14. Histogram presents the cost of propane per month. The curve represents temperature. So here's temperature, and here's propane cost. But let's look for some patterns. Okay. Let's see, it appears when temperature is high, propane is down cost. Looks like when temperature is lower, propane cost is higher. Does that make sense? Because propane is used for heating. Heating things. The central air, hot water, cooking. So it can't go to zero. So I would suspect in the summer session, in the summertime when it's high heat, but the only thing you're spending on your propane is for your hot water and cooking. And when temperature goes down, if you notice during the warmer months, it's pretty much a constant, doesn't change. So there's some fixed cost, fixed amount. Like I said, I'm thinking stove, hot water. And we assume that's kind of like a constant over the entire year. That kind of tells you what your heating bill is, or what goes towards your heating. Okay, this over a 2-year period. So what can we now infer from those things? Can't move it. How nice. So choose the best description of the behavior of the variable temperature. The temperature rose continuously. Well, it's not just doing that. The temperature declined continuously. Nope. Temperature rose and fell. Yeah. The temperature rose and fell repeatedly. Ooh. So it rose and it fell, and then it rose and it fell. Yeah, it's got to be this guy. This is the more accurate one. Let's look at the cost. The cost rose continuously. No, that means we just kept going that way. Decline. Nope. Yes, it rose and fell. But more importantly, it rose and fell repeatedly. So fell, rose, fell, rose. Basically implying there's a pattern, and there is. Because the graph gives two pieces of information, it is an example of a bivariate. Choose the best description of the relationship of the behaviors. The two graphs have basically the same behavior. Yeah, it rises and falls. Two graphs have different behaviors. Yeah, not in sync. That's why basically when one is rising, the other one's falling. The two graphs have the same type of behavior, but at different times. Combination of the first two choices. So they're rising and falling, but not in sync with each other. They're out of sync. One rises, when the other is falling. 180 out of sync. So let's see, as of March 31, American Civil Engineering Society, conducted joint engineering, yeah. As of March 31, the average total income of response to survey was $103,497, including all that stuff. During 12 months, but excludes overtime pay. Full-time salary engineers holding doctorate degrees have median income of 116. Those with masters is 95.5, and bachelor's 85.9. Median income shows a consistent increase with increased engineering experience. Okay, the higher your degree, the more you make. All right. Exhibit 12 reports income by professional responsibilities in engineering trade. Graphs follow the shape expected, rising from full-time salary median of $55,000 for engineer 1 to $150,000 for engineer 4. So, basically, more experience, the more responsibility you can take on, the more money you make. Okay, that's all nice. Intro, question 3. Okay, so let's see. According to the excerpts from the Engineering Income and Salary Survey Report, what was the average total annual income of people who participate in the survey? As of March 31, average total annual income, $103,497. Average income. Remember, this is all income as a amalgamate. You survey other engineers, how much you made, and on average, they made $103,497. I mean, someone may have made only $10,000. Someone else may have made $1 million. So 103,497. Yep, right out of the survey. Does the second bullet point give information about mean or median? All right, let's read the second bullet point. Here's the first, second. Full-time salary respondents holding doctorate has a median income. Those with a master's degree, median of. Those with a BS, median of. Okay. So it's a median, and we call it, what median means? Median means half the people have a salary below that amount, half of them have a salary greater than that amount. So median income, half the income is less than 116, half of the total number of incomes is over 116. Okay. Not on average. This is a position on the list of incomes from high to low. So the answer is median. Yes. Third and fourth. 1, 2. Refer to which two variables? Median income shows a consistent increase with increased experience. So 12, report income by professional responsibility, engineering grade. Okay. Again, it's, income, salaries. All right, well, it can't be salary and benefits. All right, so nothing about working conditions. Nothing on benefits. So it must be salary and experience. Yep, here we go. Let's look at the specific words. Income or salary increase with experience. Responsibility, engineering grade, that's experience. And as you gain experience, you increase salary. So the answer has to be B. Okay. All right, well, that's it for that section. So let's see how confident you can understand the meaning of the word univariate and bivariate. I would think pretty good. Univariate, one variable, or one part of the data, and bivariate is two pieces of data. Measuring central tendency, that means your mean and your median. Mean, add up all the values, divide by how many. Median, ordering from high to low, or low to high, and picking the middle value. How come you read a graph that includes two variables? Yeah. That you can read information engineers. Sure, why not? And we are done. So, with the Lesson 9C preview tutorial for quantitative reasoning online, so we have this first part completed, and I'll see you shortly on doing the questions for Part 9C preview assignment.